So we need to determine the limiting value of this given function when x approaches 0. Now we will be doing a trigonometric substitution here in such a way that the rational function, which is the argument of the inverse cosine function, 1 minus x squared over 1 plus x squared, becomes some function of cosine of the cos function. So how do we do that? So we will begin by assuming that x is equals to tan theta. Now of the 6 trigonometric identities, we are using specifically tangent of theta here. So why are we using only tangent of theta and no other choices? So the reason being, we have two terms in the rational function. So we have 1 and x squared in the denominator. So what we need to do is we need to change it into a single term. So if we replace x by tangent of theta, then this becomes an identity. So let's work on this. So if we consider x to be equals to tangent of theta, then our function f of x, which is 1 over x cosine inverse of 1 minus x squared divided by 1 plus x squared, changes to f of theta, which will be equals to 1 over, so x becomes tangent of theta times cosine inverse of 1 minus tangent squared theta divided by 1 plus tangent squared theta. Now we know that 1 plus tangent squared theta, this is an identity. So that is going to give us 1 over tangent of theta times cosine inverse 1 minus tangent squared theta divided by secant squared theta. So we're using the identity that 1 plus tangent squared theta equals secant squared theta. So now the denominator is now reduced to a single term from two terms. So now what we can do, we can easily separate the two terms in the numerator. So we have 1 over secant squared theta minus tangent squared theta over secant squared theta, which will be equals to 1 over tangent of theta times cosine inverse of, now we have 1 over secant squared theta. We know that secant squared theta is the reciprocal of the cosine function, so that means 1 over secant squared theta will be cosine squared theta. Also, tangent squared theta will be the ratio of sine squared theta over cosine squared theta, and secant squared theta is 1 over cosine squared theta. So when we substitute for tangent squared theta with sine squared theta over cosine squared theta and secant squared theta with 1 over cosine squared theta, we're going to get sine squared theta. Now cosine squared theta minus sine squared theta is another identity, which is cosine of 2 theta. So this is the identity of cosine squared theta minus sine squared theta. So that means now we have 1 over tangent of theta times, so cosine inverse of cos 2 theta is going to give us 2 theta. So that means now our function is in terms of theta. So let's write it down here. So we have f of theta is equals to 2 times of theta over tangent of theta. Now we are going to change the value of x. So when x is equals to 0, so we have tangent of theta, which is equals to x, is equals to 0. So that means theta must be equals to 0. In other words, we can say that when x approaches 0, theta approaches 0. So we have limit theta tending to 0. So now our function is 2 theta over tangent of theta, which is equals to 2 times the limit of theta approaching 0, theta over tangent of theta. Now theta over tangent of theta, the limiting value is going to be equals to 1. So we have 2 times 1, which is equals to 2. So the limiting value of our given function is going to be equals to 2. Let us do another problem. So here we have 1 over x multiplied to secant inverse of 1 plus x squared divided by 1 minus x squared. Now we know that secant inverse of x is actually equals to cosine inverse of the reciprocal of x. Now if let's use this identity. So we have limit x approaching 0, 1 over x times cosine inverse of the reciprocal will be 1 minus x squared divided by 1 plus x squared. And this becomes exactly like the previous problem. So the limiting value of this given function is going to be equals to 2 when x approaches 0. Let's move on to the next question. So here we have the function 1 over x multiplied to tangent inverse of thrice x minus x cubed divided by 1 minus 3x squared. So here we are going to assume that x be equals to tangent of theta. Then this, on doing so, what we get here is then 3x minus x cubed over 1 minus 3x squared. So this becomes, so let's take the tangent inverse of it. This becomes equals to tangent inverse of 3 tangent of theta minus tangent cube theta over 1 minus 3 tangent squared theta. Now this is an identity. This identity is actually the expansion of tangent of 3 theta. So that means tangent inverse of tangent of 3 theta will be simply equals to 3 theta. Now we'll also find the value of theta when x approaches 0. So when x is equals to 0, so this implies tangent of theta is equals to 0. So which implies theta must be equals to 0. So therefore we have limit theta approaching 0. So we have 1 over x. So x here will be now tangent of theta, and tangent inverse of the function is 3 theta. So we have theta, and 3 being a constant, we can take it out of the limit. So this is going to give us 3 times 1 because the limiting value of theta over tangent of theta is 1. So the final value is going to be 3. Let us do another problem. So we have to determine the limiting value of the given function when x approaches 0. So let us begin by assuming that x is equals to tangent of theta. So that when x equals to theta, or when x equals to 0, this would mean that tangent of theta is equals to 0, which implies that our theta value is approaching 0. So we have limit theta approaching 0, 1 over x. So x becomes tangent of theta multiplied to tangent inverse of 2 tan theta over 1 minus tangent squared theta. Now 2 tan theta over 1 minus tangent squared theta is the expansion of tangent of 2 theta, meaning we have limit theta approaching 0, 1 over tangent of theta times tangent inverse of tan 2 theta. So tangent inverse of tan 2 theta is going to give us 2 theta, 2 being a constant. We can take it out of the limit. So we have limit theta going to 0, theta divided by tangent of theta. So the limiting value of tan theta over tangent of theta is 1. So that leaves us with 2. So this is going to be the limiting value of the given function when x approaches 0. Let us do another problem. So here we assume that x is equals to sine theta. That's because when you substitute x with sine theta into 3x minus 4x cubed, we get 3 times of sine theta minus 4 of sine cube theta. So this is an expansion of sine 3 theta. So now we have sine inverse of 3 sine theta minus 4 sine cube theta. That will be simply sine of 3 theta. So that gives us 3 theta. Also, we need to find the value of theta. So when x is equals to 0, then we have sine theta. So we have sine theta equals to 0, which is possible when theta approaches 0. So that means now our limit changes from x to theta. So we have theta approaching 0, 1 over x. So x here is sine theta times sine inverse of sine 3 theta is going to be 3 theta. So that gives us 3 times the limit of theta tending to 0, theta over sine theta. So theta over sine theta, the limiting value is going to be 1. So our final answer is 3. Let's move on to the next question. So here we have the function tangent inverse of 2x divided by sine of 3x. So let us begin by dividing the numerator, which is tangent inverse of 2x, by 2x. Now 2x, this is an extra term, so we need to multiply by twice of x. Then we have sine 3x in the denominator. Now we're going to do is multiply by 3x and also divide by 3x. So 2x over 3x, that will become 2 over 3. Now we apply the limit. So we'll limit x approaching 0. Tangent inverse of 2x divided by 2x. So this is going to be the first limit. And the second limit will be limit x approaching 0 twice x over sine 3x. So as per the definition of limit, the limiting value of tangent inverse twice x over twice x is going to be 1. And the limiting value of 3x over sine 3x is also going to be equals to 1. So we have 2 over 3. Let's move on to the next question. So here we have the function sine inverse of x plus 2 divided by x squared plus 2x. We need to find its limiting value when x approaches negative 2. So what we can do first, we can rearrange the denominator. That means we're going to factorize the denominator. So we have sine inverse of x plus 2 divided by, so x squared plus 2x, what we can do, we can take x as the common factor. So this is going to leave us with x plus 2. Now let us do a substitution here. Let x plus 2 be equals to y. Now this will help us to find out the limiting value of y as well. So when x is equals to negative 2, so this implies that y is equals to 0. So we now have limit y approaching 0 sine inverse of y divided by so we have x plus 2, so that will become y, and we have x, so that will be y minus 2. So we have limit y approaching 0 sine inverse of y divided by y times the limit y approaching 0, 1 over y minus 2. So the limiting value of sine inverse of y divided by y is going to be 1. And substituting for the value of y, we have 1 over 0 minus 2. So that means the limiting value of our given function when x approaches negative 2 is going to be equals to negative half. Let's do another problem.